Okay, fellas, welcome back. We're just in a short lesson. We're going to look at part 3 of our trigonometry study, which is inverse trig ratio. So let's begin. All right, so remember before what we were trying to do was find the missing side, right? And you did that on the quiz today. And we used the normal trig ratio, sine, cosine, and tangent. Remember SOHCAHTOA is how you remember which one is opposite over hypotenuse, which one is adjacent over hypotenuse, is which one is opposite over adjacent. So we've been given sides and we've found sides. Now we want to find angles. So the way we do that is to find the missing side of a missing angle of a right triangle. We can use inverse trig ratios. So there are 3 of these. Okay, they have names. They're just the opposite of basically the opposite of what we learned before. So instead of sine, cosine, and tangent, we have inverse sine, inverse cosine, and inverse tangent. So the symbols for this is, many people call it sine -1, cosine -1, and tangent -1. And that's a completely wrong way to say it, okay? The -1 notation in math is used for inverse. So maybe from algebra 1, if you remember this function, right? F of x, that's just a function, right? That just means y. And f of x inverse is what this one is called, okay? So basically, f of x, you plug in x and you get f of x out. In the f inverse, basically, you switch that. So instead of plugging in x and getting y, you plug in y, and it will give you the x back. So they're sort of like just opposites of each other, right? And the analogy goes like this. Normal trig ratios are when you put a quarter into a gumball machine or a soda machine, right? You get a soda out, right? But an inverse would be you put soda in the machine and get money out, which is kind of nice, I guess, depending on how much money you're getting. So this time, notice in the last couple problems, what we did was when we wanted to find a missing side, well, we first looked at the angle, then we figured out what sides we had, and we basically picked the SOHCAHTOA, sine, cosine, or tangent based on which sides we had, right? So if we had opposite over hypotenuse, we use sine, adjacent over hypotenuse, we use cosine, and opposite over adjacent, we use tangent. So we're going to have that same idea, but it just depends on what you want to find. So if you want to find a side, you use the normal trig ratios, the ones that we've been doing so far in our trigonometry study. We're going to use the inverse if we want to find angles, missing angles of a right triangle. So now in the parentheses here, what you're going to put, instead of putting the angle, right, since we're looking at the inverse, right, instead of put the angle in the parentheses, we're going to put the ratios. So whatever the ratio is for the opposite over the hypotenuse, that's what goes in the parentheses there. And basically, if you plug this left side into a calculator, it's going to spit you out a number which will represent an angle, okay? So remember that for an inverse sine, we're going to use opposite over hypotenuse ratio. The cosine, we use the adjacent over hypotenuse ratio. And tangent, we use the opposite over adjacent ratio. And again, all these are going to just spit out angles, right? So it doesn't matter what the name is, A, B, C. In the problems, it will matter because, it'll specify which angle to find. So again, our goal is to find angles now instead of sides, okay? So it goes like this. Basically the same idea as we did last time, which is figure out what sides you have and which angle you're starting with, okay? Then figure out which trig ratio those sides match up with, and then we're going to plug into a calculator. I'll show you exactly how to do it. So for example 12, it says find the measure of angle A to the nearest tenth. So I'm going to go over to angle A, okay? And I'm going to ask myself, first, identify which sides I have, number 1. So in relation to A, I have 18, which is the opposite, and 27, which is the hypotenuse. So since opposite and hypotenuse goes with sine, I'm going to use sine. But since I'm trying to find an angle, I'll use inverse sine. So the inverse sine, okay? Now, what numbers do I put in the parentheses? Well, instead of putting an angle, because I don't know the angle, that's what I'm trying to find, I'll put the ratio in, so the opposite over hypotenuse. So that's 18 over 27. And that will spit me out the measure of angle A. Now, all you have to do, you can go on your calculator. You can go to Graph and Calc 83, our best buddy here. And notice that we have above sine, cosine, and tangent, it looks like sine -1, cosine -1, tangent -1, right? Inverse sine, cosine, and tangent. So what you're going to do, you're going to hit the second button. And notice now inverse sine comes up instead of normal sine. You type in 18 divided by 27, boom, 41.8, and you're done. So the answer is 41.8 degrees for the measure of angle A, and that's all you have to do. Okay. All right, let's try another one. So 13, find the measure of angle A to the nearest tenth. Again, we're going to find the measure of angle A. Okay, that's what angle we need. So in relation to angle A, we have 3, which is the adjacent side, 15, which is the hypotenuse. Remember, it's across from the right angle. Okay, so since we're given the adjacent hypotenuse, we're going to use cosine. But since I want to find an angle, I'm going to use inverse cosine. And again, in the parentheses, instead of the angle, we put the ratio. So the adjacent is 3, 15 is the hypotenuse, and that will spit us out the measure of angle A, which is what we want. Once you set that equation up, again, let's go back to Graph and Calc 83, hit second, cosine, right? So it's going to give us inverse cosine. 3 divided by 15, boom, 78.5, we'll call it. Now notice one thing I'm not doing here is I'm not simplifying the fractions inside the parentheses. And there's no reason to do this because you're just plugging into a calculator, right? So there's no need to call 3/15 1/5. You would get the same answer if you did it, right? So let's just, oops, that's not what I want. If we take a look, inverse cosine of 1/5, you get the same answer, okay? So there's no reason to simplify. I'm not going to know really what you plug into a calculator. So you can simplify, but I would say no because, again, that just introduces a place where you can make a silly mistake, okay? All right, so this last one, 14, I want you to find the missing angle, okay? Try your best, see what you can do, and then I'm going to do it. So, again, we're trying to find the measure of angle A. So we're given 6, which is the opposite, 20, which is the adjacent. So opposite over adjacent is tangent. Since we're trying to find an angle, we use inverse tangent. Now, opposite side is 6, adjacent side's 20. And again, inverse trig ratios give us angles. So the inverse tangent of 6 over 20, go back to Graph and Calc, 6 over 20, boom, 16.7. And that's our final answer. Okay. All right, well, that's all she wrote for this section, okay? I try to keep it short. So again, the point of this, what we're trying to do is we're trying to find the missing angles of a right triangle now instead of finding the sides, okay? So we use inverse trig ratios to find the sides. Sorry, inverse trig ratios to find the angles. And we plug those into a calculator by hitting second, either second sine, second cosine, second sine, second cosine, second tangent, right? That'll give you all the different ones that you need, okay? All right, so I'm going to post a Delta Math homework for you. This is all for this section. I hope you enjoyed, and I hope you have a great weekend. And I will talk to you, God willing, very soon on Monday.